Hello again. We're continuing our discussion of limits of functions, and we're going to talk today about determining whether or not a function is continuous. So let's get started. The first concept is being continuous at a point, just a single point. So a function is going to be continuous at a point if the limit exists at that point, meaning the y values are approaching the same y value. The function exists at that point, and the function and the limit are equal to each other. So there's three things that we need to show in order to show that a function is continuous at a single point. Okay, here's some functions that are not continuous at a point. So counterexamples of each of those things. So if the limit doesn't exist at that point, then the function isn't continuous, like it is not continuous here at x equals 0. There's a clear break in that function, and the limit from the left and the limit from the right are not approaching the same y value. Here's another example where the limit does exist, but if you look at x equals 0, the function does not exist at x equals 0. That's the third example. And then here's another situation where the limit exists, the function exists, but they are at different y values. So the limit is approaching y equals 0, but the function at x equals 0 is equal to 2, and those are different. So this function is not continuous at x equals 0. All right, a function is considered continuous everywhere if it's continuous for every single point on that graph. Now, usually there are some where you know that they're continuous. Polynomials is an example of that. Basically, if I can draw the entire function without lifting the pencil for a break or for just like a dot, a momentary dot before you continue on with the same path, if you can do that, if you can draw it without lifting your pencil, then the function is continuous everywhere. Okay, so here's an example. I want to determine whether this function is continuous at x equals -2. So the limit is everywhere that x is approaching -2. So I'm looking at the top piece for that, because that piece applies to all x's that are not -2, so greater than or less than -2. All right, so as x approaches 2, I'm going to be looking at that piece of the function. If I factor the x squared minus 4, I get x plus 2 times x minus 2. The x plus 2's divide out, and I'm just left with x minus 2. If I plug -2 into that, then I get -4. So the limit does exist, and it's equal to -4. Now I need to see if the function exists. Well, I'm looking at f of -2, which means I'm looking specifically at when x is equal to -2, so I'm looking at the second piece of that function, and it does have a y value of -4, so it does exist. Are they equal? Well, I just found that the limit was equal to -4. I just saw that the function is equal to -4, so yes, both are equal to -4. So that means that the function is continuous at x equals -2. So that's one type of question I can ask you. Basically, is the function continuous at this point? Second kind of question I can ask you is, let's assume that a function is continuous, but I'm missing some numbers in the function, and I want you to figure out what those numbers are. So each of these pieces of this three-piece function is linear. Y is equal to 7 everywhere that x is less than or equal to 1. Y is equal to 19 everywhere greater than or equal to 5, and then there's some different linear function in between those, in between 1 and 5. So I just want to make sure that they line up, and it is continuous at x equals 1 and at x equals 5. So at x equals 1, the left-hand limit, basically every y value before I get to 1, is going to be equal to 7. All right, and the right-hand limit is going to approach a times 1 plus b, so that's just a plus b. And if this is continuous, those two limits need to be equal to each other, so I can write a plus b equals 7. And as you can see, this is going to turn into a system of equations where I'm solving for a and b. When I look at x equals 5, the left-hand limit for values of x that are slightly less than 5 is going to be a times 5 plus b, which is 5a plus b. And the right-hand limit is going to approach the 19 for all x's that are a little bit bigger than 5. So I have my second equation, 5a plus b equals 19. And as I said, that's a system. You can solve that any way you want to, and I will get a equals 3 and b equals 4. So that's the second kind of question I can ask you about whether a function is continuous everywhere. That's it for this lesson. If you have any questions, please let me know, and I will see you tomorrow.